In the previous video, we introduced Game of Life and began constructing our application. In this video, we're going to re-evaluate our life class's initializer. Along the way, we'll discuss lazy variables, closure expressions, and function value types. We previously created a class named life that used two nested loops inside of its initializer to initialize our grid. To keep our code clean and readable, we're going to extract our loop logic out of our initializer. As always, we have some options for doing this. We could call a function or a class function from our initializer, and for processes like these, those options would work great here. For this example, however, I'm going to use a lazy variable. Lazy variables are usually better suited for cases where you either don't want to spend the resources until the variable is called, or for when your data isn't ready until a few moments after your application loads. Having acknowledged the use cases for a lazy variable, and despite the fact that we could easily use a function here, I'm going to utilize a lazy var for this scenario simply because it'll lead to some interesting dialogue in a moment and again later in this course. First, we need to initialize our cells array to avoid property access errors. Then we'll initialize our cells property using a lazy variable, which we'll name assign cells to grid. Let's create our lazy var. I'll go ahead and paste it in now. This is a simple operation. We create an array of cell and use nested loops to iterate over each item on the x-axis. Then, for each item on the x-axis, we're populating every value on the y-axis, thus populating our grid with cells. Finally, we return the end value to our initializer. Although I don't consider lazy variables to be an advanced topic, there are some interesting things going on here, so it's worth taking a moment to discuss. As you've certainly noticed, our lazy variable doesn't contain a simple object type or a primitive type. It's holding a closure type that takes no values and returns an array of cell. Functions are types, just like ints, floats, arrays, and almost everything else in Swift. However, there's not just one simple function type. Instead, each function signature represents its own unique type. Consider the following example. Here our type is a function that takes two int parameters and returns an int as denoted with the following type signature. If a function has no parameter, its type is simply an empty set of parentheses or just void. Let's continue with this example by explicitly assigning this type to a variable. Since we have set our function type as our variable's type, we can safely set the value to that of our multiply method, giving our variable the ability to accept and return values. We can then use this method by calling our variable and passing in two values. This is not dissimilar to what we're doing with our lazy variable. Picture instead of using the function's name multiply, we just use a closure expression and our multiply functionality within. Both function exactly the same. So, looking back at our code, our lazy variable is actually a function type with a closure expression. Before we move on, you may be wondering what this weak self-in means at the top of our closure. We'll be discussing weak and unknown references in Section 3, Memory Management. But for now, just understand that we're telling the compiler to make a weak reference to self, which helps to avoid possible memory leaks. But with this, we have successfully removed our logic from our initializer. In this video, we explored closure syntax and identified a function value type. In the next video, we're going to take a look at one of the most useful features in Swift, extensions.